Sally the scientist is tracking turtles that are colonizing the islands of the Florida Keys. Right now, she is studying one of the larger islands called Great Island. This year, let's call it Turtle Year 0, 3 turtles managed to swim to the island. She returns in 1 year to see if the population has grown and discovers 6 turtles. In 2 years, there are 12, and in 3, there are 24. She collects data for 5 years. She calls the year X and the number of turtles Y. Can you see any patterns? We start with 3 turtles and then double the turtles each year. So how many turtles would we have after 10 years? After 10 years, we have doubled 10 times. We have an initial value of 3, which is multiplied by 2 10 times. We can write that using an exponent. 3 times 2 to the 10th. 3,072 turtles. That's a lot. Now, let's write an expression for the number of turtles after X years. 3 times 2 to the X. Y equals 3 times 2 to the X is an exponential function. Y is the number of turtles after X years. It's called an exponential function because X is the exponent. This exponential function has a special structure. Y equals A times B to the X. B is called the multiplier. It determines how fast the turtles increase. A is the initial value, that is, the number of turtles in year 0. From our table, we can make a graph. The graph shows us that the turtles increase at a faster and faster rate as time passes. The multiplier of 2 means rapid exponential growth of the population. The initial value is visible here at the y-intercept of 3. Exponential functions can be represented with tables, equations, and graphs. We recognize this is an exponential function because there is a multiplier causing the growth of the y values. We can see the multiplier here and here. We can see the initial value here, here, and here. An exponential function is perfect for modeling the growth of turtles on Great Island. Use exponential functions to model scenarios where values increase or decrease based on a constant multiplier.